Hey guys, sorry I'm not there today, but we are going to do a lesson anyway about adding and subtracting radical expressions. So I hope you have your math encyclopedias out and you can, on your next blank page, label the title Adding and Subtracting Radical Expressions. You can add or subtract radical expressions when they have like radicands. So that means that the number that's under the square root symbol has to be the same. That's the first thing I want you to note. You can add or subtract radical expressions that have like radicands. Which just means that the number that's underneath the square symbol or the square root symbol is the same. So we're going to work our way through a couple examples and you're going to figure out that these are super, super easy. So for example, example A. If we had 3 root 7 and we added 8 root 7, the radicands are the same. The radicands are both root 7. So you're going to think about these just like they are like terms. If I had 3 root 7s and I add 8 root 7s, how many total root 7s do I have? Good. If you said 11 root 7s, you are good. 11 root 7s. So you're just basically adding just like you would if they were like terms. Let's do some others. So that was example A. Here's example B. If I have 9 root y and I take away root y, how many root y's do I have? So what is my hidden coefficient here? Good. If you said -1, I'm proud of you. Good job. So we have 9 root y's and we're taking away 1 root y, and so 9 take away 1 is, yay, 8 root y. Good. So these are really super basic. Let's try a more difficult one. Let's do 12 root 2 take away 4 root 11. So in this one, they don't have similar radicands. So what you're going to think to yourself is, can I simplify those any further? So when you look under the radicands, can you simplify them any further? No. So those of you out there that are confused right now and saying this makes no sense at all, you are absolutely correct, because this cannot be simplified. Good. And you might see that every now and then. Good. Okay, I'm going to give you one that I want you to do on your own. See if you can figure it out. So if I have -8 root 3d and I'm adding 6 root 2d and I'm adding 10 root 3d. See if you can figure this one out, but remember, you can only add terms that have like radicands. All right, hopefully I gave you enough time to figure that one out. So what you should have noticed is you've got 2 terms here that can be combined and 1 term that cannot. So the ones that have the 3D, since those are similar, or sorry, those are like, those can be combined. So I'm going to have negative 8 plus 10, and negative 8 plus 10 is 2 root 3D. And then I have this positive 6 root 2D that cannot be combined with anything, so that is my final answer. So this would be one that if you had been given that, you would say that that cannot be simplified. That's as simple as it can get. Good job, guys. Okay. Now sometimes you're going to have expressions that are being added that you have to simplify before you can add them. So, for example, this is example letter D. If I had root 12 plus root 27. Neither of those right now are as simplified as possible. So we want to get them first as simplified as possible. So remember, to have these simplified, you need to pull out the perfect square that goes into both of them. So what perfect square goes into 12? Well, that's going to be root 4 times root 3. Now what perfect square goes into 27? Good. 9 root 3. So now we're going to simplify those further. What is the square root of 4? So I've got 2 root 3. And I'm adding, what is the square root of 9? Good. So I'm adding 3 root 3. So now I have like radicans, and I can add those together. So I've got 2 root 3's, and I'm adding 3 root 3's, and I have 5 root 3's. Yay! Good job, guys. Okay. Let's do one more, and then I want to show you the distributive property. Okay, let's try this one. I'm going to give you a little bit of time so you can do this on your own. Let's do 5 root 28x plus, take away 8 root 7x. Try that one on your own. Okay, so let's talk about what perfect square goes into 28. You should have said 4 and 7. So then I'm going to have my final simplified expression here is going to be 10 root 7x, because I multiply my 2 and my 5. And then over here, I already have 7x that can't be simplified, so I just have take away 8 7x. That just came down. So 10 take away 8 is 2 root 7x. Good job, guys. Okay. Now let's talk a little bit about the distributive property. We've already talked about how to multiply radicals, so you should be fine with this. Remember, you multiply coefficient times coefficient and radicand times radicand. Wow, this is not writing very neatly. Okay, so let's say, for example, I had root 2 times the quantity of 5 plus root 12. So you're going to take that root and basically, just like you would if it was a constant out in front, you would multiply it by each piece. So what's root 2 times 5? Good, 5 root 2. And then plus, what's root 2 times 12? Good, root 24. And now let's simplify them. So what's the perfect square that goes in the root 24? That's root 4, oh sorry, root 4 times root 6. Jeez. So this one is going to become 5 root 2 plus 4 is going to simplify, and what's 4 going to become? 2, good. 2 root 6. Can you simplify those any further? No. That is your final answer. Okay, one last one, and then we will be done. And then the rest of class, you can work quietly and respectfully in your assigned seats. So let's do root 3 times the quantity of root 3 minus root 5. Alright, so what's root 3 times root 3? Root 9. And what's root 3 times root 5? Root 15. One of those can be simplified. It's a perfect square. Good. So it's 3 minus, and no perfect squares go into root 15. So it's just 3 take away root 15, and that is your final answer. Alright guys, now you've got some work time. I hope you're able to get your homework done and have a wonderful day. I will see you tomorrow. Okay, bye.